Hello, this is my presentation for my poster that I submitted to Next Generation Solar at the University of Montreal in May of 2014. The topic of my presentation is low temperature native oxide-based surface passivation in silicon. My co-authors are my colleagues Heidi Potts and Zahid Chowdhury, and my professor Nazir Karami. Some background about the topic is that surface passivation of crystalline silicon is typically done by heating the substrate up to 800 degrees. This can be bad for thin substrates and can lead to impurity and bulk defect migration. Additionally, this requires excessive energy. This project is based off earlier work done by Zahid, where he used native oxide to grow oxide on the interface before depositing silicon nitride, except the issue with his process was that the native oxide growth could take up to a month. So the goal of this project was to speed up oxide growth, keeping the native oxide characteristics through the use of ozone. The proposed solution is obviously to speed growth through ozone. This is advantageous because ozone-grown oxide is done through radical-mediated growth and results in lower oxidation states being oxidized first, which results in more uniform growth. Growth can have less stress than thermal oxide growth, and additionally, there's a constant etch rate of the oxide, implying that it is of a constant density. Fabrication of the samples was done with a starting polished monocrystalline substrate between 12 and 17 ohms per square centimeters. The thickness was 500 microns, and it was dipped in hydrofluoric acid to strip off the oxide, and then oxidized in an ozone chamber, and then plasma-enhanced chemical vapor deposition was done with the precursors of silane, nitrogen, and ammonia to produce silicon nitride on top of the oxidized layer. Characterization was done with photoconductive decay measurements through QSSPC with Sinton machine and through spectroscopic ellipsometry. Results so far have been up to 1 millisecond lifetime using QSSPC methods and up to 1500 milliseconds or microseconds at using micro PCD measurements. Future work involves parameterizing the oxide thickness versus lifetime, investigating the interface with advanced probing techniques, and adapting the recipe for use in multicrystalline substrates. Thank you for listening to our presentation, and have a good day.